Well, hey, we are back, 3D30. So hello and welcome to the next episode. It has been a little while. We had some trade shows here. Today, we're going to be talking about the new face of American manufacturing. And this has been a subject, it's pretty interesting when you look at all of the supply chain challenges that we're having globally and trying to bring that back in country. There's been a lot of discussion around it. So it's going to be a great topic today. So this is 3D30. 3D30 is Velo3D's LinkedIn Live and YouTube Live channel. We host this every 2 weeks. I'll put that in air quotes because the schedule does change based on what's going on in the market in terms of trade shows or other events. So make sure you follow Velo3D to get the latest schedule, and we'll be advertising and broadcasting on that. So as I mentioned, we're talking about supply chain today. And if you look at like US manufacturing, plenty of case studies have talked about companies and capabilities being offshore for decades. And now, because we have global issues, supply chain shortages, the US and other countries, not just the US, obviously, looking to bring back domestic manufacturing and regrow that capability. Now, the markets in the industries where we work in, aerospace, defense, and energy, this is extremely true, and it's critical to the function of those industries. But what we're seeing is not necessarily trying to rewind the clock and go back and bring back what was here 50 years ago, but actually an attempt to go with the concept that America is an innovation leader and to keep that alive and strong and to leapfrog ahead. Thankfully, there is a technology that Velo3D is at the heart of, and it has been helping a number of these industries grow. It's an advanced manufacturing technology that we all know as additive manufacturing or 3D printing. And a growing number of companies are leveraging this technology to unlock designs that have been trapped on paper or trapped in computers or trapped in simulation, but really haven't been able to be realized in actual metal before. And now that's happening. Some of the companies you'll probably recognize the names: SpaceX launcher we've had on the show plenty, Aerojet Rocketdyne, we've done some case studies with them, Astra, Honeywell, Lockheed Martin, Siemens Energy, and more. The list goes on of these success stories. To help us talk about some of these movements and success stories, we're bringing on Mike Corliss, VP of Technology at Godwin. I'll show Mike here. So don't forget to bring your questions. This is a live show. We want to hear from you. But Mike, welcome to the show. How are you doing today?
Great. Thank you, Mike, for having me. Look forward to our discussion today.
I know, it's going to be fun. Can you tell us a little bit about your background?
So I've been in precision manufacturing for over 41 years in oil and gas primarily. And I've seen all aspects of the manufacturing from the shop floor all the way up through management. And so I've seen quite a bit in the industry from precision machining across all industries primarily.
And now with Godwin, what does Godwin specialize in?
So we specialize in precision contract manufacturing, build to, make to order for our customers. So we're a large precision manufacturing facility, 244,000 square feet, over 200 something employees, over hundreds of CNC machines. So, and we basically build to print, manufactured really precision products.
And you're located down in Texas?
Yeah, so we're in Texas, Katy, Texas, just outside of Houston, just west of Houston.
So you guys are having nice weather like we're having here in Florida.
Oh, it's lovely right now. Triple-digit weather.
I know. No, congrats for that. Yeah. Get the AC going.
Oh, yeah.
So, and I imagine that's where a little bit of the oil and gas background comes from, is kind of being in the heart of it.
Yeah, we're in the heart of it. That's been something that we've been through thick and thin with it. And one of the reasons we did choose additive was to try to steer out of that and be more diversified and have different types of customers for more diversification. Okay. So we could, maintain our workforce and everything, because oil and gas sometimes can be real brutal on you.
Absolutely. As can a lot of these industries we're finding out really soon, right? So you've got a kind of a blend then, conventional manufacturing, additive manufacturing. How would you compare the two in your mind?
Well, what we were doing years ago, we were really heavy in the precision machining. And when production was real heavy, working with our customers also had engineering departments that were looking to develop and build a new tool. And they were coming to us as well for these engineering projects. And that was challenging for us. And so that's where we looked at having a different type of manufacturing process in our toolbox that we could give our engineers something that they could work with much quicker, another process of manufacturing to help speed up the lead time for them. And so that's where our core strength has come in, is the ability to add additive to our core manufacturing capabilities.
And do you see additive now taking over your floor, or how do you see it working with the precision machine?
It's complementary. I mean, so we're a precision machine shop, and so we look for real precision parts all the time. We're looking at that and how we machine those parts, and manufacturing engineering of those parts are very complicated. So additive manufacturing, we needed a process that mirrored what we were doing. So we needed a precision printing process that could give us what we were looking for with very close tolerance, but less machining, so we can adapt it with our regular machining processes. So a lot of the products that we do that were traditionally machined, now they're additive in the post-process with some of the other equipment. We see that we're moving some of that process from very complicated 5-axis machines over to some of the more standard CNC machines. So we're not overburdening some of those higher complex machine tools.
And we got a call out from Scott. I don't know if you could see the comments here. Scott Volk, he's saying hi.
Yeah, hello there.
Hey, Scott. Good to hear from you. So, a couple of things that we've noticed is just that we get some complementary synergy between the two technologies. And I imagine you're seeing a little bit of that as well.
Yes. Like I said, when you're looking at the precision details of a subtractive part, and then we've got to produce it with additive, and then we still got to do the post-processing. At the end of the day, we have to deliver the same quality product to our customer that they were used to receiving from a traditional manufacturing process. And if we incorporate additive to that product, it has to be to the same quality and same standards that they were used to seeing.
And we've got a part here that I think does a really nice job of showing some of that synergy, where you can kind of see these machined surfaces, but then you've also got kind of the matte finish of additive manufacturing printing. Could you tell us a little bit about this part?
The part is it's a really interesting part. This was a multiple piece part. So it was a dozen components, and then they were all merged together into one. And then we machined the necessary features, the close tolerances and threads, and then everything that could be left as printed, we left it as printed. So all the millwork was eliminated on this job. So we didn't have to do any millwork at all. We just had to do lathe work. So we cut out a complete resource flowing through the facility.
You can see all these tiny little holes kind of on the right-hand side of this part. What's going on that side?
Those are flow passages, unique flow passages, very complicated flow passages. It doesn't represent what it looks like on the inside, of course. And so those are very long processes that you had to do on different resources, and then put it all together and stack it all together, and you could make the part. Where we took that and now we printed that all in there, and with slight modifications, we use the Sapphire system to print those details with no supports and a really nice surface finish in there. And I believe that, if I'm not mistaken, that the flow rates were really good compared to some of the previous stuff done.
And this one was IMI's part, which is now, what industries are they looking to sell into for this?
They're in the valve industry. These are disc stack parts, so they're in the industry about replacement, one-offs, urgent, field, repairs in the fields, get some parts to the field location quickly. So that's just the valve industry that they're in.
Okay. And, as far as kind of industries, I think there's some that wouldn't surprise anybody, but what industries do you see in your shop that you're using additive manufacturing to solve challenges for?
Of course, energy. Then we see the space and aerospace industry, turbo machinery industry. Those are the heavy industries right now with additive manufacturing. There's other industries that are, starting to pick up, but those are the heavy ones in our industry right today.
And what are you looking for when moving to additive? Like, what kind of benefits do you get out of that move to additive?
Well, we're looking for shorter lead times, of course, and cost
Okay.
reductions. The whole topic of this is to look at what we can do to, be competitive. Now some stuff like you talked about early on in the beginning, that some stuff is coming back our way, and we're seeing activity. And so now we have to be able to offer a very competitive product to our customers. And additive is one of those tools in our toolbox that is allowing us to be able to add value to the product and the customers being attractive to it. So that's the thing, is just getting very complex parts printed without compromise and produced and precision machined to give the customer the end results that they're looking for.
And you mentioned kind of time. What type of time savings? Like, what would be the difference using additive versus like a precision machine?
Yeah, some of and we have parts, we have components that take 22 weeks, very complex components that take 22 weeks through our facility now. Some of those parts I can print in 15 days and have it to the very near net shape. And then you just have to do some post-processing at the end. So you're looking at some very significant lead time reductions. Now, one thing to keep in mind, and I always tell everybody this because this is a misconception, when we print, it's not in the raw material condition that you can buy the raw material in. You still have to do some post-processing to get that material into the heat-treated condition or solution annealed condition. So there are some steps there that still have to be done, even with printed parts. So that's something that takes up and adds a few more days here, weeks there for lead time. So if you're hipping, solution annealing, and aging, you need to do those processes to the part.
So you still might be looking at like 4 or 5 weeks versus 22 weeks. Is that kind of the comparison?
5 weeks versus the 22 weeks.
Yeah, that can be pretty big difference if you've got a multi-million-dollar facility down for a couple $1,000 part.
Absolutely. I mean, and that's the big game changer there that you can use this technology for, is to be able to act quickly and respond quickly to customers.
And I know, talking with Max from Launcher, how much they've been able to accelerate their timelines and getting their development done. And I'm kind of thinking like other industries. So space, I think people get it. There are these iterations. What other industries would be negatively impacted if AM weren't here? Like, where would we be for some of these industries that have adopted additive?
Well, even we see it in the energy industry. I mean, we've worked with engineers that have taken 3 and 4 designs because they're not really settled on what they need. And we may print all at one time and give them all 4 different designs at one time, and then they can go back and work with that. So it has definitely sped up the R&D side of development of new products. So speed to market, that's the whole thing, is the quicker they can get the products, the quicker they can get the product to the market and start generating revenue. So energy, turbo machinery, I think, is going to be a big industry that's going to take advantage of this because of the fact that they're going to take products that took months and years to develop and produce and build and test, where we can print something maybe for them that looks very similar in a one-piece configuration. You take 60 parts and put it into one, and you do it in 50 hours. That's just amazing. When all of a sudden the pacing item used to be this component, now it won't even be the pacing item anymore for the customer. So those are just some really phenomenal numbers to look at, that what you're going to be able to reduce the lead times on some of these parts.
Yeah, it's pretty awesome. Do you see some industries maybe haven't taken the leap that are like right there looking at the industry?
Well, you have the automotive industry that's, the high volume, different alloy materials than what we're used to in, say, the oil and gas, energy, turbo machinery, and space even. So you have the automotive where they're still using different materials, and that we haven't addressed those in the additive market as well. There's other technology that may have, but we're seeing that the high-end automotive, that's really starting to take off with utilizing this technology, because they can do a lot with the printing and get a lot of advantages. And so they're taking advantage of that right now.
And you mentioned kind of the materials side. Are there materials in the automotive industry that we should be looking at that we're not looking at today?
Yeah, there's the alloy materials, the milder stainless materials, even aluminum. I mean, aluminum is, I mean, my opinion on aluminum has been that nobody's really settled on a particular aluminum in the industries. We're dealing with some casting grade of aluminums, and we can print those today. There's some high strength aluminums out there. Those are going to be high runners for the automotive industry as soon as we can find which one is going to be the more commercial available and commercially used aluminum out there. And then, like I said, the alloy materials, some tool steel materials, those are materials that are out there, and just haven't seen a lot of activity on those yet. But I feel like those are going to be some avenues that we'll pursue down the road.
So some big market opportunities coming potentially.
Yeah, for sure. For sure.
Yeah. And now you've been using additive how long? For how many years?
It's 13 years now.
Okay.
We've been using metal AM. And yeah, it's been one of those things early on, it was very challenging. But as we've progressed and working with the customers, educating our customers, getting our customers more involved in what we can do for them, a lot of the products that we originally started out with, we produced in-house subtractively, and we saw them as candidates for printing when we know what the problem areas of the lead times for doing some of those, where you're like over here on this machine for a very long time, we could print that. And so we went through our parts and just started picking them and like going back to our customer and saying, look, we can print this, it could be cheaper, or combining parts. I mean, we've got products that we combine multiple pieces. We produce 6 pieces into one. We produce, right now we have a customer that we produce a 25-piece component into one, a 41-piece component into one, a 60-piece component into one. And that has sped up the production of those parts and the quality too, because there was welding involved. We omitted all that welding.
So, I mean, it sounds like you mentioned a couple of value propositions. There's some performance advantages, consolidation, and consolidation may be being led to cost potentially. Are those sort of combined a little?
For most cases, cost. There's sometimes that, when you combine some of the parts, it may take longer to print. And at the end of the day, it may cost more up front, but the total value of that part is cheaper because it lasts longer than the traditional part. And we've seen that. And I think when our customers look at that and go, wow, the total cost of this product is going to be cheaper in the long run. It may, even if the unit price goes up slightly, but the total cost is going to be cheaper to the customer.
Okay. So so I guess time to market, consolidation, cost, performance, sort of some big drivers when you're looking at a portfolio of parts to say this looks good as a candidate or not.
Yes,
seems like a pretty clear.
We do that. We look at it, every new product coming in now, basically and not just new, we're looking at all repeat orders, and we analyze all of that. And it's like, hey, this part, we need to convert this part to an additive part because we have a lot of problems producing this, or this lot of lead times on this part to go through this, or we have more NCRs on a particular part than we like. And it was like, okay, we can omit that by taking and printing this part and then producing it with additive. And then we get back with our customers and let them know, look, we want to look at this and entertain printing this part and find out if it can be a candidate for that or not. So, but we go through that with all new orders coming through, and we analyze that.
And you mentioned an NCR. For those not familiar with the acronym, what would that be?
Non-conformance report.
Okay.
So, if something, you have all these multiple processes and you have something slightly out, you write a non-conformance, you submit it to your customer, but we can omit a lot of that when we sit there and we take out all those steps and we print it as printed. We can omit a lot of that too, and help speed up the process.
Nice. And just for anyone on the audience, this is live. We are looking to answer any questions you may have. So if anyone would like to know anything, I'm going to take a quick chat or a scan here. There's a question, anything on AR, but I don't know what that acronym would be. So if you could let me in on the acronym and what you're looking for, we'll be happy to field that question. So I'm curious, you mentioned challenges, and every time we talk about all the benefits, folks immediately want to know what the challenges have been. So, with your 13 years, 13 being a lucky number, I imagine
hey, it's
hopefully it's a good year. So what are the challenges been? What have the challenges been to getting to 13 years with AM?
Education, educating the customer, educating our machinists that are handling and doing the post processing to the parts. Early on, this was always taught to everyone with additive. It is a disruptive technology. That's absolutely true. It's disruptive. You're going to bring in a technology that you're bringing in something that it's different than a casting. It's closer to near finish than a casting. It's closer tolerance than a casting in most cases. So you're bringing a product to the shop floor that your operators are going to like, whoa, I really got to indicate this part in very closely and make sure it's right, because I don't have a lot of extra stock here and there to machine this. And so because we took all that out and only machining the necessary things. And then our customers, educating them on what we can do, what mechanical properties we can meet, how we can achieve the same results or better with the product if we made a few tweaks and changes to the part. So it's been the biggest challenge. We're seeing progress across the board with this, that people are adopting it, looking at it for various reasons that you mentioned earlier. There's all kinds of reasons for looking at adopting this technology because of the supply chain issues and things that's been across the board. And we're looking at all that and trying to always educate the customer on that and bringing them aware to what we're able to do and advancing in the technologies, and that's always advancing. So we're always bringing it to them, new technology that we could offer them.
And for customers who are sort of new to bringing something to additive, I mean, there are terms like technology readiness levels and really formal descriptions. But in terms of this technology being ready to make certain types of parts, where would you see it? Where do you see it fitting? Is it still in the prototype phase, or do you think it's gotten more to production?
No, we're in the serial production today.
Okay.
Most of our stuff is beyond the prototype. We still prototype. There's a lot of new parts coming in the door, but we're now focused on production, setting up. We're running 24 hours a day, 7 days a week. We have machines that we're just flipping them over and over, and we're seeing serial production. We're getting repeat orders for hundreds of components over and over, and so we're definitely beyond the prototyping stage.
Awesome. So I do have a question here. They want to know if there's any feature that you would like to see in terms of mass manufacturing automation on the Velo 3D platform.
Oh, interesting. Any feature.
I'm taking notes.
Yeah, that's a tough one right off the top of my head. There's things that there's a lot of advances going on right now in the technology. We're working with those, still not familiar with all of the new stuff yet coming out. But we're working on that with them, with Velo, of course, some feedback with them. So, there's the calibration side is very strong. We've seen some advancements in the pre-calibration on the Velo system. That's really good. We just got some new updates on some of the Assure software. That's a tough one to just throw out there. I don't really have anything that I would say that comes to the top of my head right at the moment on that.
Well, you mentioned some of the new things that have been going on, so maybe we'll jump into that. You've got some new capabilities in your factory now.
Yes. We have 6 Sapphire Systems. 3 of them are in Inconel. One of them is titanium, grade 5. The other one's a GR COP 42. And then we have the new XC in Inconel platform that is coming up online right now. I think we'll be, by the end of the month, we're going to be real close to being online with that system. And that's actually going to give us a lot of ability to scale up the production. Products that we were running on the standard Sapphire systems, we're going to be able to scale up and run on the XC platform. And you're going to see a really increase in productivity and decrease in cost.
And you mentioned GR COP 42. What is that from a material point of view?
It's It's the Glenn Research developed this copper 42. It's a chromium niobium blend of copper used in space primarily for very high heat displacement products that are traditionally made out of other materials, and then you go with this and it dissipates the heat much better. And it's used in space quite a bit, and a lot of other applications, and you're going to see quite a bit of products probably transferring from Inconel to the GR COP material. At least we hope so.
And then, so what kind of opportunities are you seeing? You mentioned the titanium and the copper. What does this open the door for you to do that you can't do today?
Well, I mean, of course, the geometries that we're working with are very complex geometries, and we struggled early on with different platforms to be able to print these geometries in those materials. We probably wouldn't have even dreamt of doing it. But now with the Velo Sapphire systems in those materials, we have the ability to print those products without compromising the design, working with our customers to make sure that they understand what we're going to be able to give them. So that's going to be what we're going to see the advantages of that. And there's other applications for the copper materials. So we'll see some of that in the heat exchangers and things like that coming up.
Nice. And I'm going to try and load up a couple images here once this thing loads. I think this is, this might be on top of us, just pardon the interruption here. That is the Sapphire XC platform.
That is correct.
Yeah. So that you're getting on site, obviously a bigger build chamber, bigger platform. Where are we with that one, with setting that up?
Yeah, it's I think it's going to be fired up today or tomorrow. Be doing a lot of acceptance tests running all next week. So we've got a week away, but we're excited about it. It's going to go to a 600 millimeter diameter build plate by 550 millimeters tall, and that's going to be able to allow us to work on a lot bigger components, single components, and also it's going to give us the ability to put a lot of components in there for serial production. And you have 8 lasers, and that's real exciting to see with the 8 lasers working in there.
Yeah, we just recently shared a picture of an impeller, and it was going through the Solicon depowdering system.
Yes.
And just with the scale of it, if you're not, ready for it, it's pretty impressive. You look at it, you think, well, that must be something like about, fit in my hand. But you're talking about impellers that are, 20 inches on that order that could weigh 150 pounds now that are going through these machines.
It's impressive. We have one of the products that ran on the XC, and it is very impressive. Everybody that sees it, it just blows their mind that part is that big, and it's printed as a printed part. So it's exciting. It's going to open up a lot of opportunities with the additive manufacturing.
I said, well, and with new capabilities, new systems comes new hiring. So, one of the questions we didn't. That's my segue. How do you go about hiring for these roles? What are you looking for in candidates? Where have you found anything that works?
Well, we've hired over the years. We've stuck with our tried and true methods. Is we have manufacturing engineers and CNC programmers that know how to make these parts from raw material. And like I mentioned earlier, you have a new tool in the toolbox. So we've taken those types of employees and adapted them over to the additive, and they applied, they learned all about the additive, of course, and everything. And then they applied what they know with the subtractive world. And they know what we're looking for at the end of the day, a precision component that we can make on the machines and do post-processing and get the same results. Like I mentioned earlier, the same results that we normally saw with our precision machine parts. So that's been the challenge, is finding those type of employees and growing. So we've grown from within for the most part. We've had some new hires that are from outside, some manufacturing engineers, but we're seeing the activity. We've got some interns that have worked with us, and we're excited about them when they're graduating. They'll be coming in from the academia world and helping us and contributing to our core group.
And now they get to work on systems. Here we go. That's a better looking image.
Yeah,
now they get to work on systems like that.
Yeah, that's going to be exciting.
And parts like the Aerojet copper.
Yeah. So that's GR cop material there.
Yeah. So NASA grade copper, 8 lasers, printing. Oh, we got a new picture here. Oh, that's on the build plate where they chopped it in half, so you can see.
It's sliced in half. You can see the channels going through there, the geometry. You can look at it and you can tell that it's all printed without supports. And there's some stuff in there when the wire cut it in half. There's in those holes a little bit, but yeah, it's real impressive. We've seen some really good results from it so far.
Nice. And now you mentioned kind of getting customers to look at the challenges or to overcome challenges, getting customers to adopt the technology. Well, what do you see as like the big transition in the mental mindset that they need to do to accept additive?
Well, some of our customers are adding departments and starting to adapt it. Working with our traditional customers, our engineers, a lot of them, don't have the time. I've seen that our customers, they're always looking forward. So new products coming out, they're using the additive technology and adapting it. It's what's hard and difficult is to go backwards, and because a design is set. And when the design is set, it's very challenging to go backwards and incorporate additive unless you pretty much keep it the same. You just produce it differently. So you don't get the real benefits of it. And a lot of times, if we could go in there and say, hey, let's change this, let's tweak this, and we can make this much cheaper, or shorter lead times. And they work with us as much as they can on that. We eliminate welding, we eliminate lead plugs, we eliminate a lot of the ancillary stuff that goes onto a part. We can eliminate that by printing it all in one now. But unless you're working on the front end and going forward, it's very challenging. So, but all of our customers that are adapting or using additive are always, they're putting teams together to understand additive software, understand additive. And so we're starting to see designs come out from our customers with additive applied to it.
All right, well, we've got one more question here from Lance, and he's looking to understand what are some non-geometry related things you look for when deciding if a part would be a good application for additive?
Well, we look for the overhangs, the shapes of geometries. We're looking at surface finish requirements in areas. If it's an area that we look at that we want to print or leave printed, but if it has a very close tolerance or a surface finish, then we're talking to you and asking you, what can we do here? Can this be done differently? And so those are some of the things. Threaded features, we're always going to put stock in O-ring grooves, seal bores and threads. We're always going to machine those, as you saw some of the pictures earlier, because those usually require good surface finishes, sealing and things like that. Even though we print really dense parts, we still want to go back and machine those parts and create the seals and the surface finishes to the tolerances that are there. So we look at that. And I can tell you that we've, over the years of looking at parts, and we've done this where we've taken subtractive parts that we've made for 30 years. And we talk to our customers, hey, can we print this part? And the next thing you know, when we start discussing and talking about it, 80% of that part could be left as printed and only 20% of it that needs to be machined now. And we're going like, wow, all these years we spent all that time machining this thing and putting all these nice finishes. And now we can leave this as printed. So we ask now, especially when we see new designs coming through, we ask, what can we print? What can we get away with just leaving as printed with a surface finish of this and a tolerance of that? And so that's some of the dialogue that we would have back and forth with our customers.
Nice. So I do notice we're over 30, so we're going to wrap up here. Do you have any final thoughts for folks that have been joining us today on what your experience has been, or just any thoughts on the industry in general?
I think the industry is really going in the right direction. And I mean, I wouldn't hesitate to look at parts and push it. I mean, we've been pushing it. So, the old saying, pushing a train uphill, that's what we felt like we were doing for a long time. Now technology is starting to catch up and take advantage of some of the things that we've been doing, and it makes it easier for us. But I would definitely look into additive, look at it, explore it, talk to us about it, what we could do for you, because additive is here to stay, and we're going to be producing parts this way for a long time to come.
Very good. And last question. What's the best way for folks to get in touch with you if they want to contact you directly?
Yeah, you can email me at mcorliss@kgsbo.com, or you can reach me by 281-371-5408. Call me on my direct line there, and be glad to talk to you about your project and what we can do for you.
Well, there you go. And thanks, Mike. I love this story. I love the synergy between things. To me, that's where this innovation lies, and to see how the precision machining is combining with the additive. They're not exclusive. They work together. Even hiring.
Yeah.
You mentioned, you've got kind of precision machining working on additive parts is kind of this gateway to understanding what additive capabilities are. Really awesome story. Thanks for joining us today, and thank you everyone who joined and sent in questions. Our next session will be in 2 to 3 weeks. Who knows? Stay tuned on LinkedIn to get the latest schedule. Make sure you follow us and follow KG or Knus Godwin online, and send Mike a note just to say hi if you want.
Thank you all.
See you.
Thank you.
Yeah. Thank you.